First of all, it is very important for all of us that construction engineering and management or all this stuff is the main purpose of when we talk about the construction management is related to managing a project. Okay. So with the advancement in technology, of course, with the passage of time, it has revolutionized all the different industries as well. Okay. When we talk about the information, okay, or all the information or the IT industry, it is not, of course, the IT itself is nothing. It has a lot of applications, okay, in every industry. Similarly, uh, similarly, the construction industry has also been revolutionized with the advancement in the technology. Of course, if you look since the human has been start working, so of course, if there's any technology which has been innovated or has been developed, it is widely adopted in different sectors. Okay, so I'm not going to go into the background or the history. So we're going to start from today. So I will just give you a brief project management framework overview. Okay, so in which how we are going, how we are able to manage the project in a better way. Okay, for example, data acquisition. Okay, so because every project starts from the design. Okay, so for the design, we need to have the survey. Okay, so surveying technique has been there for several decades or even centuries. Okay, so they are all traditional methods. Now we have this optical instrument which has been very accurate, but the problem was this, it was time consuming. So nowadays, now you know that we have very advanced data acquisition techniques like UAVs, like what we call drones. We have the laser scanning. Okay, when if you want to map anything underground, we have the different technologies. Of course, for the civil engineering or the shallow, we can say the ground penetration radar or radio waves that we can use. Okay, so then once we gather the data, okay, what's the next thing which is more important? We have to have the design. Okay, we have to have the design. It can be in the form of BIM or 3D models. So, and then how the new thing which is coming is intelligent construction. When we talk about the intelligent construction, what does it mean? It means that intelligent construction technologies, which include the different automated technologies, like we have automated machine guidance, we have the uh, compaction rollers, we have different other type of machineries which we try to automate. Okay, and then there's a fleet management system in which we try to control, or there's a control center in which we try to control different activities. When we talk about the visualization is very important to understand our progress. Okay, so we can use VR, or we can use BIM or simple UAV, or we can have the progress update. Okay, so I won't be going in very much detail in every topic, so I will give you a overview of uh, brief overview of all these topics, and maybe if there's a question we can go in detail. Okay, let's go ahead. Okay, for example, when we talk about, let's go to the equipments. Okay, so as you know that generally when we talk about the automations, okay, the tower crane is also a type of a, a technology which has revolutionized the building of the building industry, in which, or the tower cranes are used in even mega projects which help us to improve the productivity of the system. Similarly, you know that artwork is a very important part of every project. Okay, so when we talk about what's the difference between the manufacturing industry and the construction industry, okay, the problem with the construction industry is this: we always have to produce the new products. Okay, so its automation is really difficult. Or in case of the industry, if you have to make a one Toyota car model, you're going to make this 1,000, 100,000, or 1 million these Toyota parts again and again to develop a one product. Okay, the product is one. Okay, but in case of construction industry, our environment is also constantly changing. In a manufacturing industry, our environment is controlled. Okay, so we can control the operations. Whereas in the uh, construction industry, our environment is also constantly changing, and also our product is unique. So what we are trying to do is that the earthwork is a major part of any project. If you talk about the if you're building a stadium project or a concert hall, or you are developing a hydropower dam, or even you are going to have some mega structure building, these are very important part of the earthwork is a very important part of all these construction projects, even the railway, roads, airport, any type of pavements. Okay, so and it is also one of the most time consuming, and also because the survey is involved and we have to get the points every time. So what the researchers or what is the latest technology is doing is this: minimizing the surveyor's work. So we know that this machine we can save a lot of time. Okay, so for example, when we talk about the ICT equipment, okay, intelligent construction technology equipment, if you look at this excavator, okay, this excavator looks like a simple excavator, but no, it is not a simple excavator. Okay, it has a GPS, so it is a smart excavator, or you can say semi-automatic excavator. Okay, so for that excavator, we also got a machine guidance excavator. We don't need a surveyor, because the operator knows in XY direction that where his bucket is. Okay. Similarly, these roller looks you a very simple roller, but this roller has this antenna with the GPS, and also this drum use a very advanced technology, and on the base of the isolation of the vibration of the oscillatory, it can tell the operator about the compaction information. Okay, and there is one grader. Okay, so it's also not a simple grader, it also have GPS antennas on that, similar with a dozer. So what is happening is that once we get the design is modeled, we are able to see the operator on the operator screen. We are able to visualize it. Okay, so I'm going to take an example of the excavator, and we will talk about it more in detail about it. Okay, so because 1 hour session, so we cannot cover everything in detail, so I'm just giving you a brief overview of the this type of technologies. Okay, moving ahead. Okay, so when we talk about the, okay, go ahead. Okay, this is similar. Okay, so when we talk about the machine guidance, okay, so basically the machine guidance is a machine control integration of positioning. Okay, so in the construction industry, basically there are many type of hardware and software solutions which are combined together to provide a current position. Okay, so why, if you just go to the basics, why we need a surveyor in a construction industry or in earthwork operation? Because we want to know the XYZ location of our current any specific point. So that's why we ask the surveyor, please can you measure that point, or we need to go down, or did we done, because everyone is worried about the over excavation, because it is going to cost you the money for this excavation, and also maybe you need to do the backfill work. Okay, so what is happening is that in that case, like, so there's a modern technology which is called the machine guidance technology. In that, you can see that this type of screen. Okay, so this type of screen in which you are able to see the x square xyz location, and it can be shown in a real time to the operator, so the operator knows that where his bucket is. So all the time which has to be wasted for this for surveyor, so for surveying, it can be saved so easily. Okay, so this is one of the very latest and modern technologies. Okay, okay, how does it work? Okay, you have to understand the basics. Okay, so because as you know that the GPS is becoming very much accurate nowadays, and every different countries have their own GPS now, so it becomes more accurate. Okay, so basically it's an extension of the traditional survey. Okay, so what is happening is that there is like a GPS. Okay, so there's a GPS attached to the excavator. Okay, so and what is happening, the GPS tell you the location, the GPS tell you the location of the location of that machine, okay, where it is. So this, but this GPS may not be very much or that much accurate. Okay, so there's like a base station we established. Okay, so maybe on the next slide we can have it. Okay, so we can establish like a base station from where we are getting the more accurate signals, or we can use the RTK GPS, which is the real-time GPS. Okay, RTK GPS, real-time kinematics GPS, it provides us very accurate location, as I think as much as like 0.1 of a centimeter. Okay, so in a practical field, this is not like, I'm not talking about the theoretical numbers, I'm talking about the practical numbers. Okay, so what are the major components in these type of equipment? Okay, so it can be a roller can be a little different. Okay, but the overall the working principle of the basic mechanisms are same. Okay, so we have this GNSS receiver here, and then we have this GPS antenna. So of course all the information which is getting from this antenna is having this receiver. Of course it is getting all this information, it is processing it, and there will be a one display unit in the cabin on which the operator can see it. And then we can have like different type of sensor, like IMU sensors can tell you what is the angle of these two, and what is the angle of the arm of the uh, arm of the excavator, and also what's the angle of the bucket. So from there, this all calculation is happen using the simple kinematics. Okay, let's take this example. Okay, let's take this example. This is from our published work um, with Dr. Wakas. Okay, so as you see that now, this is a real site work of for a trench for the installation of a new underground facilities line. Okay, underground facilities. So you can see that this was a design of the excavation in a 2D drawing. Okay, and this is like we put that you can call it a BIM model because it has information. Okay, it has some information in XYZ, but this can be a first level of information. So this BIM model is input in a excavator. Once it is input in excavator, now this is a screenshot of the real time screen which is seen to the, or what is like what the operator sees in his cabin. Now once he knows that what is my X, Y, and Z is, so he knows that how much I need to go down more for achieving my design. He can have like the different views, he can change the angle in any spec. So this is what we want to achieve. So now you understand that we don't need a surveyor anymore. Okay, so by just using a drone, you just go through it, you have the basic idea, and then you can move forward. Okay, so because this is based on the surveying. Okay, so because once we have a survey, so we can develop our design in a BIM, and then we can translate into any type of different machinery. Even we can have we can same type for the graders, even for the rollers. So we are moving. Okay, the objective for these using these technologies is to improve the productivity and to improve the efficiency. Okay, or make the system more effective, and maybe we can work on the principle how the manufacturing industry work. Okay, so let's talk about the drone for surveying. Okay, maybe it is becoming very common in Pakistan, like not very common in Pakistan yet, but of course it has been adopted nowadays in Pakistan as well. Okay, so what's the purpose? Okay, so why won't you use a drone? This is like the ARC, Aerial Imaging Limited from England. It was it's a published in which they tell about this information, like we are have it's a time and cost saving. Okay, So even it can be programmed to automatically map the sites, and we don't need to worry about the obstacles. For example, if there's a their slopes are very steep, so maybe the surveyor is unable to go there, or maybe there's a water, or it's a very un, unreachable areas are there on the actual sites. Okay, so it removes these type of risk to ground and air personnel, and all of course it is more rapid. So if we look at this, the normal survey, we talk about the traditional surveying, it to accept the survey takes like 1 to 2 days, and then the data collection and the processing take 1 to 2 weeks, and the delivery of the PDF and the CAD file will take 1 to 2 weeks. So generally it will take 2 to 3 weeks. Okay, so this is the same survey, like comparing the same type of survey. So with a drone, plan to collect the data, it will take like 1 day. Operating a drone and collecting the data 1 to 2 days, and delivering the PDF or even 3D models and point cloud, it will take 1 to 2 days. And the total survey can be done in 1 to 4 days. So imagine that how efficient this survey is. And also this is compatible to the BIM. So once you get a data, you have this point cloud, you can just import in any different softwares of the BIM, and you can view them directly. And as you know that the point cloud is not now LiDAR, and the point cloud is not something like very expensive technologies. Okay, they are expensive depending upon the nature, like how accurate they are, but all these iPhone 12 Pro and iPhone Pro, or 13 Pro Max or 13 Pro, they all have these functions. So maybe if you just go and install ScanVerse, if you have one of these phones, you can just make a point cloud of any space. And people are nowadays working on that for developing, uh, for just comparing accuracy using a LiDARs and the mobile phone, just for the feasibility analysis. Okay, and they are pretty happy with that the mobile is good enough. You just go and you can have scan the environment, and you can develop the feasibility of a project, and it will be quite accurate. Okay, for example, how the drone works. Okay, so first of all, simple, you just need to fly the drone, and of course it will be equipped with some camera and with the GPS. So in that case, we have collected the data 775 images. Okay, so just a capture. So it was a very good, uh it was DJI Spy 2, or like, I don't remember exactly, but it was a very good drone with a high optical lens. So you just take a pictures, and once you have the pictures, then you can pre-process the model. There are different softwares. Okay, this is done using the Pix 4D mapper. So what you do, these images are calibrated. Okay, so and then there's a average ground sampling distance. Okay, and there's like the number of the calibrated images. So these are all the information. And look at this. So just flying a drone, we have the average density per meter cube is 113.36. So imagine, like, 1 cube of a meter, you have 113.36 points. So you know the XYZ of that point. You can improve it depending upon the performance or efficiency of your computing and the machines. Okay, and the total 52 million densified point clouds has been generated. So once you process it, you just get in a software, and now you look at this. Oh wow, you can just have the 3D. You just have the 3D model of your project. So you have a control in XYZ for your project. Now you can plan better. Even you can make your designs, or you can use this map for different things. So you can do the noise removal, and also to make it more accurate, because there can be a lot of error. And of course the drone survey is not accurate by using the simple GPS. So what you do, you develop the benchmarks, or called the GCPs. Okay, so these are the known references. Okay, so like this one, the mark red. So you measure XYZ using some technique which is like more accurate, maybe using traditional survey, or maybe you are using RTK GPS. So just measure these 7 or 8, 9, 10 points. Don't go more than 15 in one project, and it should not be less than 8. Otherwise it can compromise your accuracy. Okay, it should be more than 8 and less than 15, and you can just calibrate them. with your model, so it will more make them more accurate. Okay, so it is also very important to you should know that what is the sensitivity of the project. Okay, so on which you can use a drone. Of course, it is an earthwork project, or you are doing the earthwork of any project. Okay, good enough. But imagine if you are making anything which is very sensitive, like any type of hydropower dams, and now you are pouring the concrete and you have to be very fixed. You cannot use this type of photogrammetric techniques yet. They are not as much accurate yet. Okay, but for the earthwork, of course, which is one of the most advancement in recent decade, is that you can save a lot of time. Okay, and also you can measure the quantities just by here. You can click around it and you can measure the quantities. Okay, so you should know the sensitive. Based on your sensitive of the project, you can select which type of method you want to know, you want to use. For UAV is very good for any type of artwork. Generally, for example, if you are going to make a road, generally the error can be between the people have improved it like 1 to 2 centimeters. The 1 to 2 centimeter of the surveying error for the earthwork is not something very big nowadays. So even you can reduce it if you have like a very good calibration points and very good optics, or if you have very good drone. Okay, so based on the sensitive project, you can use the photogrammetric technique. Okay, next thing. Okay, so there's a video of one of the projects. Okay, so here is like the point cloud of one of the project. Okay, so now you can see that we have the control of all these things. So even we are going to do any work, or we are going to develop a new road or reconstruct a road, or we are having any land development project, or we are going to make a stadium here or anything, we have the control over the area. So even we can plan our fleet management as well by looking all these areas. Okay, so this is just was that. Okay, this is like something which is not related to our these slides. Okay, so until now I have discussed the basic technologies. Okay, so okay, now we go around this. Look at this. Okay, so okay. Okay, so look at this. Okay, so look at this. So this is a screen of a excavator in which we are going to have a trench. This is like a automatic excavator. So what we have done, what we do, so we can do the survey. Okay, so once we have a survey, okay, and then we can like calibration points using or we can use a laser scanner if it's a land development project, because instead of drone, maybe the laser scanner can be more accurate and the time saving as well. And once we have the control of the area, we can use it. Okay, so this was from this side. This is not all from. Okay, so another important thing which we are using nowadays is the VR or AR technology. Okay, so everyone is very BIM or AR and VR, and it is very advanced, or looks very much in fashion. But we have to look in detail about this. What is the virtual reality or augmented reality for our for civil industry? Okay, civil engineering. Okay, so this is the second part of our lecture. So before moving into second part, we are almost mid of the lecture. So anyone has any questions right now? So you are welcome to ask. So anyone has any questions? Okay, be very confident. This is more like a discussion. Okay, so anyone have just like got any question in that, or okay. Okay, so no question for right now. Okay, so pretty okay. So okay, so there's one question that how georeferencing is done. Okay, So go in more detail about the georeferencing. Okay, so when we talk about the georeferencing, is that like what you do? What you do is that once you take you done the survey using a drone, of course it should have some built-in GPS, but it will be not as that accurate. Okay, so what you do that while you fly the drone, you mark some points. Okay, just make a cross or something, make them known, okay, in your survey. Okay, so what you do when you fly the drone, you should use, there are different type of techniques, but you can just put a plus sign with a red markers or red paint. Okay, and what you, so when you fly the drone, so these are also recorded in your imagery. Okay, so what you have to do next is that measure these points what you have marked. Okay, take the center point or like a specific center point of that cross or any point on using any traditional technique. Maybe if you want to use the traditional survey, maybe you can use it. Okay, or if you want to use the RTK GPS, you can use the RTK GPS. Just measure as much accurate as you can do. Okay, so once you have these points, okay, now you know exact of these points. So what you do, in many software like even Pix 4D, there's an option. So what you do, you go on the software and click that point. Now, because this plus sign or the cross sign is also visible in your survey. Okay, so what you do, you click on that cross, on your cross point, and measure and you can manually enter these 8 or 9 or 10 points. Okay, so it automatically reference and it distributes the error in your survey. Okay, because what you're doing is that these, we will assume that these points which have been measured using traditional or RTK GPS are more accurate than our current model. Clear? I think it should be very clear, that process what I told you. Okay, okay, so let's move ahead. Okay, application of virtual reality for the AEC industry. Okay, so okay, so before we are going to the virtual reality, I'm just going to give you overview of the history of the BIM, because VR is also, or the AR is also linked with the BIM. Okay, and in Pakistan, maybe we are always very late in adopting many technologies, but of course, imagine that 1982 the AutoCAD was released. So in 1982 there was some people who have been using this computer drawing or developing the computer drawing. Okay, so and 2000 the Revit is released to create the first BIM system. Imagine in 2000 we had this BIM tool was there. Of course, it was adopted in the architecture industry, but it was there. So it is like 2022, since the 2022 years have been passed, still we are in adoption phase in many sectors. And similarly, in 2006, BIM and 3D model project reached like 25% industry adoption was there in the world. It's a lot in 25% industry adoption. And I remember that people are getting, many people are getting getting introduced about the AutoCAD in that era. But imagine at that time, the BIM and the 3D model projects reached like the 25% in industry adoption. Then we look at it in 2009, the BIM reached a 50% adoption all over the world. And of course, mostly these all are the developed countries. Okay, similarly, in 2012, the 80% was there. So 80% adoption means that the BIM is somehow in another way, it has been adopted everywhere. Okay, and in 2016, finally, the virtual reality become, or the VR become available commercially. And we can see there are a lot of VR zones in Pakistan as well. They were starting to release for the gaming purpose. But this technology is being adopted in the construction industry, and especially in architecture industry. Why? Because it gives us the real feeling of presence that in a virtual world, that how our project looks like in future. Okay, so this is like a very brief timeline, because once the 3D models are there, so now we can visualize the 3D model virtually. Okay, so when we talk about the components of VR system, okay, so basically we have to develop first a 3D model. Okay, you can either do it in Revit or SketchUp or any other BIM tool. You can develop a 3D model. What's ahead? We need a 3D engine. Okay, so for example, we have like the HTC Vive or Oculus. Okay, Oculus for the VR, uh, or even with the AR, I think the Microsoft is there. So these are different type of engines. They are the different functions like lights, elevators, and equipment. Okay, and there's like the 3D engine is there, and then we have the VR sets, which I told you about already, and we need to have the material cost or even all the schedule information which we can embed in these type of the VR models. Okay, VR, the process of VR is fairly simple to take a design from the concept to the presentation. Okay, it looks very good. Okay, number one, what is the first step? I'm just giving you, the VR is not something like a rocket technology. Okay, it's a tool for better visualization. It's like what you call the PowerPoint. Okay, or just in which you just want to show your ideas or present your thing. So what you do, the design team conceptualize. Okay, as soon as the design team has come up with the conceptual design in 3D, a VR model can be created. Okay, and the next thing is the information. Okay, building information established. Functionality and the information are added to the model. Like what type of information you want to have into the model. Okay, like are you showing the material? Are you showing the interactive or it's a non-interactive? Like can you move in the environment? Like can you change the elevations, or can you change the, if you're talking about the building, can you change the exterior in a real time? Or if you're developing any road project, or can you change the views, or like this is how much, because you have to develop a small game. Okay, that's like the different engines in which you can use, like Unity is one of the engine. Okay, good enough. And then programming. Okay, we are engine programming. Okay, so all the components which what we need, or we need to import. Okay, we need to import. So we have to be importing some engine in which we want to do the programming, that these functions are given to our remotes. Okay, you all have played the games, so we are just like playing a game with that. So we have to program it and incorporate with all these type of functions in that. And then the last part, VR model presentation. So the VR model is presented to internal and external stakeholders, and you will have a very beautiful presentation, and you can see the future, like how the project looks like in future. Okay, so but still there are, when you talk about, there are some limitations of the VR. Okay, of course, a new technology, and there are some limitations. So this is one of the things which is really in the adoption phase nowadays. And maybe we are like the beginning when the computer was there, but we are not very used to the computer. But nowadays, you know that everyone is using the computer. Like even you go to a very small basic grocery store, you get a bill, and you know he has the database for every product you scan. Okay, so he developed a database based on the QR or that the barcode, and he just scan it, and then he make a bill based on that. And ultimately what's happening is that he's managing his inventory. So ultimately he is using a computer. So imagine that, like 20 years before, they talk about it that everyone will be using a computer, but it was really hard to believe. So similarly, the VR is in the adoption space, in the phase, and it is still have a limitation that people are also not very used to it. Okay, so and maybe there are too much complex models and maybe very detailed one, and also it depends upon the hardware and the skill of the developer. So these are limitations. Practical, there are also some practical limitations which may not be solved with time, because it has been very hard. That it's generally that the humans are, because the problem is this with the VR is this, that mentally you are in another virtual environment, but physically you are in a different environment. And as you have, maybe you have played the VR game, some of you, and you will feel that your disorientation after like 5 to 10 minutes, because your body and your mind, there's called the gyros of your mind, are behaving differently. Like you're moving, your head is moving, so your brain sends a signal that you're viewing something, but your body is not having the same situation. So it creates a conflict, and some people have the headache. However, some people are naturally born who can be used to these type of systems, like who can have a good reflexes. Like it seems like a good cricket player or a good some of the uh, sports person. They are born with natural abilities. There are very few person who can handle these type of situations. Okay, so uh, there are motion sickness when we are walking. Okay, so these are these type of the things. Okay, now this technology is becoming very cheap. I don't know, like it was very hard when we were in Pakistan to get imported, but here you just go in all the developed countries like in Dubai, USA, Korea, Japan. You just go to a normal electronic store and you can buy in like $300 or maybe $400. So VR is becoming very cheap, and maybe it can be used like one. Okay, but the professional services are also getting like 150 per hour for developing some project for you. So the equipment is becoming very cheap. Is it less than $1,000 nowadays? Okay, because this price is old, so maybe $300 to $400. No, you can have it. Okay, so what are the benefits we can get from that? Okay, it can cut the construction cost and reduce the waste. We can conduct it safety and train the people what we have to do remotely. This is very important. Okay, and we can speed up the project planning and boost worker engagement, present and market their project with a style. Okay, present. Okay, so present the project with style. Okay, so these are the benefits of the VR implementations. Okay, what is happening? We have improved communication. So this limits, like, there's a lot of conflict once we develop any project. Okay, this is not what the owner or what the client want. So but you are going to show them the future. Okay, and then there's like a business development, greater communication of vision. For design, we can have the cost and schedule saving, because there will be very less change order than design flaws. Public outreach, so maybe communicate your vision more effectively to community stakeholders. Like there are a lot of projects which are, because the community or the projects you're doing there, the community is not happy with them. Maybe you can just show the advantages of the VR to them in future. Okay, uh, stay cutting edge, proves that a firm is willing to stay cutting edge to provide the best services for their client. So when you talk about the capabilities of the VR, so show construction over the time in 3D. Similar to 4D scheduling software, the VR construction model can be attached to a schedule to show the construction development over a time. Integrated cost, show the component of cost, assemblies, and equipment while looking at the project. Remote job walkthroughs, and maybe you can, with a drone laser scanning or 3D camera, remotely view job site progress in a geographical diverse environments. Okay, so maybe with a drone or sending you the information in a VR, you can able to walk through virtually there, being present there, and show the project information in operation, able to visualize operations such as functioning product system, manufacturing process, or pre-sale or residential or retail space. You will be able to see that how this building look like in future. And maybe a lot of that a lot of 5-star hotels now nowadays give you the VR experience. Okay, because they want to give you the feeling that how you will look like during your stay. So this is like a better presentation. Okay, look at this, that now you can just capture the image, and now scanning frequently allows the team to verify that the workplace matches the original design. Okay, so the scan BIM. Okay, okay, so here like the VR. Now in a VR, you are just planning for a city, like, so you can able to visualize your project in the future, or you are just planning, oh, how these, how our skyline looks like. So if this new building, how if it's good fits in a skyline, because these buildings is just not like building this. When you have these high-rise steel structures, they are also looking out the how the skyline looks about, and how our like it's in like constructing a new building and affect the other buildings, sunlight and all the other effects, or even the wind. Or maybe you can just see like the unit project, like obtaining for the excavators, like, or the machinery, how it behaves. And also with the VR, you can have like the, you can just look at the install the look at the validation. Maybe you have your design. So even using the augmented reality with using with the AR, you can just go and look at this. Okay, it has to be in design there. Okay, very good. It has to be in the design there. Very good. So you can have very RFI punch list, and there's a lot of building information there. So you can just check it very quickly using the AR. AR and VR are almost not like same. So we cannot same, but AR gives you augmented reality in which you can see the real environment and the virtual environment together. And VR, you just have the virtual environment like a game engine. Okay. So similarly, using the AR, so you have this, you can scan the site and you look at it. Okay, so how it should look like in future. So this is like the AR document. So you know that, okay, our building will be there, and now what they are doing, are they excavating, or is there any problem in that? So they are using the AR documents in that. So this is now the VR, in which the VR, they're just looking at the model in the future, that how our building look like. They can rotate it, zoom it, or just play with it like a game. So this is also image uh like how the augmented reality, this is an example of the augmented reality in which the 2D drawings are superimposed, like 3D drawings are like viewed in a 3D drawing. Okay, look at this, how this 3D design model looks with better visualization. Imagine this, if you are looking at this similar thing in a 2D drawing, it's really hard to understand it, for the people who are not like a civil engineer. Even with a civil engineer in the beginning, it's really hard. So it gives you better understanding to the client as well. And maybe you can do the safety trainings as well. Okay, so this is also one of the part in which you can just tell them, okay, how you have to what you have to do if the excavator is close to that. Okay, a fire extinguisher must be ready to, for instance, use either misplaced on the construction site. Maybe you can ask different questions by just showing them, or maybe virtually a human can be there and perform the different activities, and you can train them for the better safety of the site, construction site. Okay, so this is all. Thank you very much for listening. And if you have any questions, you are most welcome. I don't know, the mic is open, or how you can ask. Okay.
Thank you so much, Dr. Abubakar sir, for giving this very detailed presentation on various technologies in the construction industry, the innovative and the modern technologies. So now from the participants, if you can unmute yourself and then ask the question, please.
Okay, what are the purpose of VR and AR apart from visualization and marketing or convincing the client? Okay, this is what the purpose of the BIM is as well. Okay, ultimately, the visualization is providing you some other things. Okay, it's just not like visualization. Okay, so once you have information, so maybe you will reduce the RFIs in a project. Okay, maybe you reduce the future cost of the rework. Okay, आप क्या कर रहे हो, आप टाइम से पहले बहुत सी मिस्टेक्स को आइडेंटिफाई कर रहे हो, सो अल्टीमेटली आप अपने रीवर्क को रिड्यूस कर रहे हो, सो यू आर मेकिंग अ सिस्टम एज मोर एफिशिएंट. ओके, सो ultimately visualization, marketing and convincing client, it is also having a lot of advantages track. Okay, हम लोग किसी भी प्रोजेक्ट को कंप्लीट करने का हमारा होता है कि हमारे पास RFIs कम आए, हमारे पास डिजाइन चेंजेस कम से कम आए, so हमारा प्रोजेक्ट स्केड्यूल के मुताबिक चले. One of the reason why the projects are delayed are RFIs and the change in the design or major change in the design. I think I'm able to answer you. Okay, thank you for your question. Okay, anyone else had a question? So we are, I think, done. Okay, so Dr.
Thank
Waqas,
you
up
so
to
much.
you.
Thank you so much, Dr. Sir, for giving us your precious time and giving the opportunity to all the participants to learn more about construction management and specifically the new innovative technologies in this field. Thank you so much for all the participants.
Always
We
welcome.
will upload this today's webinar on our YouTube channel, so you can follow it and you can revisit it later on if you want to. Love.
Thank you.